All right, moving on with the practice in 7.5. We'll just work through this together-ish. Kind of funny. So what do I have to have? I've got to have negative values of x and go from 0 to 6 on y. So I'm going to do this. I'm going to put my axis about, let's see, 0, 0, negative 6, negative 3. I'm going to put my axis over here. We've got to show some stuff about this quadrilateral. I'm going to put my axis that way to make this fit. Okay, we've got to show that this is a trapezoid. So we're going to have to look at, let's see here. Let me just plot the points. Q is at 0, 3. Make sure you label them. R is at 0, 6. Q to R is 3 units. I'm glad that's horizontal or vertical line. S is at negative 6, 3, 4, 5, 6, and 0. S, oh, this might not be bad at all. T is at negative 3 and 0. It's looking like a trapezoid. We just have to talk about how we know. It's a, yeah, kind of an upside down one. You know what, you guys, just because it's sitting there between the axes, take your pencil and shade it a little bit just so we can tell what we're talking about. S, T, Q, R. So we have to decide whether it's isosceles. So the definition of an isosceles trapezoid, we have to make sure that it fits it. The legs of the trapezoid are congruent. I think we've got that. The legs would be considered Q to R and S to T. And since those are horizontal lines and vertical lines, 1, 2, 3, S to T is 3 units. Q to R is also 3 units. So since these legs are the same, that fits the definition of an isosceles. Since QR equals ST, no, congruent. Let me do this. It's isosceles, but I feel like even just putting the, why didn't I spell that right? CE, there we go. LES. We also have to hit on the definition of a trapezoid. It has exactly one pair of parallel sides. This is letting us call it isosceles, but let's go hit the definition of a trapezoid. And I think that the sides that are parallel are S to R and T to Q. So I need the slope of S to R, and I need the slope of T to Q. And if those are the same, then we have one pair of parallel sides. And I'm going to count rise over run for S to R. I'm going to actually take the path, the whole path from S to R, as a rise of 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5, 6. So the slope of S to R is 1. And I'm thinking when I want to climb from T to Q, 1, 2, 3, to the right, 1, 2, 3. That simplifies to 1 as well. And since these have the same slopes, S to R is parallel to T to Q. So it's a trapezoid. So I hit 2 parts talking about legs being the same and then just that parallel piece of the trapezoid definition. It's a trapezoid is a quadrilateral with exactly one pair of parallel sides. The parallel sides are the bases. All right, now we go into these angle measures here. Find the measure of angle K, find the measure of angle L. We know that M is 23. Which other angle is 23 units? There was the base angles theorem. 23 would also be over here for L. So the measure of angle L is 23. And they also want us to do the measure of angle K. So what's the sum of all the angles in our quadrilateral? I brought this up on the other page. 360. I got 360 degrees between all 4 of these angles. And right now, if I take my 360 minus 23 minus the other 23, I'm left with 314 degrees. What do I need to do with that 314 to find information about these other two? Split it in half. I'm getting that K is 157 and so is J. So the whole idea that the sum is 360, we jotted that on our other page. I took away the two 23-degree angles, saw what was left, and split it in half. Now, what kind of a figure is number 3? What does it look like? Consecutive sides are the same. What kind of a figure is 3? Yeah, it's a weird kind of, like when I turn it this way, maybe you see the kite shape. But since this is a kite, and if we have to look back, we will, but what angles are the same in a kite? By letters, which ones would be congruent to each other here? I can see that it's got to be this L and K piece. Now, did you catch that I dropped in 90 degrees right there? So these two together, a kite is also 360. Four-sided. Sum is 360. So how do I handle what I've got, what I know about the sum is 360, and I've got 130 degrees and 90 degrees? What do I do now? Okay, so I'm getting the suggestion to add up 130 and 90. That makes 220. I'm going to take that away from 360. 360 minus 220 is 140. And then what do I do with that 140 degrees? Divide it by 2. So if I've got 130 and 90 is 220, 360 minus 220 left me with 140. When I split 140 in half, those two guys are 70. The measure, and you know what, I'm just going to get real technical here. The measure of angle K is 70. The measure of angle L is 70. Just using your correct notation. Now, before we go to number 4, I want you guys to look back. What's the relationship about the bases and the mid-segment of a trapezoid? Because this one is definitely a trapezoid. What's the relationship about the bases and the mid-segment? Flip back a page. What do I do here to find out how long C to D is? Half the sum of the bases. This is a base. This is a base. So C to D is going to be half of 12 plus 36. So C to D is half of, that's 48. What's half of 48? Think cash. Add together those bases, take half of it, and you know how long the mid-segment is. Now I feel like this one, 5, we know what the mid-segment is. We just don't know what one of the bases is. I'm going to put an X right there for an unknown. We know the mid-segment. We just don't know what one of the bases is. I could do this a couple of ways. Half 1.8 is equal to half of that sum. And that's what I was going to, yeah. Dominique said, can't you just double the 1.8? 2 times that mid-segment would be equal to the sum. And algebraically, like that actually, how do you undo multiplying by a half? Multiply by 2. So 3.6 is equal to x plus 0.6. How long's the missing CD side? So maybe it's worth a second here to back up and put that little doubling formula on the other page. I think we should do that. Let's go back to that, flip back to that theorem. And stay in here for just a second. Still see people writing. It's going to be happening later too. Which one was it? Right here. Mid-segment equals half of the sum of the bases. Or you can look at it this way. 2 times the mid-segment equals the sum of the bases. So we just discovered that by messing around. If you double the mid-segment, it's equal to the sum of the bases. It's just undoing what we had written before. 2 times the midsegment is equal to the sum of the bases. Two times the midsegment is the sum of the bases. Turn back and see if you can't think about setting up that next problem. What is it, 5 or 6? Where are we at? 5. 6. Okay. Yeah, we were just leaving off with this one. 2 times the midsegment is equal to the sum of the bases. All right, of course, we're going to have all kinds of algebra to do. Do you guys want to... Let's go at this one this way. If I double this, it's equal to the sum of these. 2 times the midsegment is equal to the sum of the bases. Let's write it out in algebra. 2 times the midsegment is equal to x plus 11 plus 3x plus 3. Right back into using our algebra, constantly using our algebra. Before I start undoing anything, I've got to do some simplifying. I'm going to simplify the left side by distributing the 2. 2 times 3x is 6x. 2 minus 2 times 2 is 4. I'm going to combine my like terms. I haven't started undoing anything. I'm just simplifying on the right. X and 3x is going to give me 4x's. 11 and 3 is going to give me 14. Now I'm in a position to start undoing. I'm going to start by taking 4x away from both sides. Negative 4 equals, 2x minus 4 equals 14. 2x minus 4 equals 14. I'm going to add 4. 2x equals 18. And to finish, I'm going to divide by 2. X is equal to 9. So we started out with our equation to solve, simplified by distributing, combining like terms, and then starting the undoing process. Looking ahead at 7, this one's a kite. I'm going to hold off for just a second, but if you are done with 6, move on to 7 and see if you can't set up the equation. There was something about a kite and their diagonals. What did we learn with our theorems about the kite and its diagonals? They meet at 90 degrees. Opposite sides aren't congruent. Diagonals are perpendicular. These are going to be congruent to each other. 9 is equal to a tenth of x minus 1. 9 is equal to a tenth of x minus 1. The diagonals are intersecting each other. This one, h to j, is going to be congruent to j to f. I don't have any simplifying to do. What do I do to solve for x? 9 plus 1 is 10. 10 equals a tenth of x. How do I undo multiplying by a fraction? Multiply by its reciprocal. X is 100. We didn't have to use x. They just told us simply to find it. Now the next move is going to be, you guys get your 7-5 practice in your hands. Whatever you don't finish in class today is going to be considered homework. And I'll be looking to check that in when you walk into class on Thursday. And I would expect that at times you guys are going to need to use your phones for calculators. If you're in my room right now, you can get up and get them. Remember, test is next week on Tuesday.